All right, so continuing our radicals unit, today we're going to learn a little bit about operation of radicals, namely adding and subtracting. And that's our learning target today, is to be able to add and subtract radicals. Okay, before we do that, let's take a look at this right here. What's going on? And once you figure that out, what would be the answer to that last equation? We'll pause here. Okay, so today we're going to learn how to add and subtract radicals. Here's how we do that. First thing you need to do is make sure everything is simplified. So what we talked about last time, simplifying radicals, that's what you need to do first. Then the second thing is once you've identified the radicals and simplified all those, then you want to identify radicals with the same index and the same radicand. Remember, this is your index. So I can only put cubes together, and that's really important. I can't put cubes together with fourth roots or square roots or anything like that. So I have to be the same index. They also have to be the same radicand. Now remember, the radicand is the number underneath the radical. So I can only add cube roots of 5 to other cube roots of 5, okay? So that's an important thing to note. All right, and now when you do this, this is pretty simple. It's just like when you go 3x plus 7x, you say, hey, what do? We add the coefficients. So we add 3 and 7, we'd say, oh, that's 10x, okay? This is going to be the same thing. You are going to add or subtract coefficients if they have the same index and same radicand. So how does this work out? Well, right away, I would say, all right, I've got a cube root of 5 and a cube root of 5 here. So I can put these together. So this is 10 cube root of 5, and this is negative 4 cube root of 5. So all you're going to do is say 10 minus 4 is 6, and then this part doesn't change. It's going to be still cube root of 5, just like the x part here doesn't change, okay? So now I've combined those, and these are really combined to be 6 root or times the cube root of 5. And then I've got this one right here and this one right here. They both are square roots of 7, okay? These have to be the same. So now if I put those together, I notice that that would be 8 root 7, okay? Now, this is as far as I could go, because this and this, they don't have the same index, and they also don't have the same radicand. They have to have both to be able to add or subtract them. So now this would be the simplified version of what we just had up there, okay? So that's how we add or subtract radicals. And let's take this a little bit further and look at a little bit of problems where I have all these steps, like simplifying. Okay, so this one right here, we're talking about square roots. So I want to simplify the square roots first. So I'm going to break this apart to, let's see, square root of 9 goes in there. So square root of 27 is really square root of 9 times square root of 3. And then I'm going to break apart square root of 12 to square root of 4 times the square root of 3. Okay, now you're going to simplify this further. 3 times 3, square root of 9 is square 3, oops, and then times root 3. Okay, and then this would be 3 times, this is 2. So this is 9 root 3 minus 6 root 3. Okay, now these are both same index, same radicand. So now I can put these together, right? So this is going to be 9 root 3 minus 6 root 3 would be 3 root 3. And this is my answer. Okay. Hopefully that's making a little bit of sense now. All right, let's take a look at another one here. Once again, start by simplifying all your radicals. So let's do that. This first one, I've got 3 times, I want to break apart the cube root of 54. So let's see, I'd use my chart here. I'd say cube root of 27 times cube root of 2. Okay, that's the first one. This second one, there's nothing to really simplify. Okay. Cube root, remember I've got a negative here, so I want to bring that in with the perfect cube. So this will be negative 8 is the biggest perfect cube that goes there, and this would be times 2. Okay, so now we're going to simplify all this, right? So this first one, let's take a look here. This would be 3 again. This one we can't do anything with. And this would be 7 times, that would be negative 2. And then all right, so what do we have? We have 9. Oops, I wrote a cube here. This should be a cube. Let's undo that. Whoopsie. All right, so now we have 9 times the cube root of 2 minus 2 times the cube root of 2. And then this will be negative 14, so I'm going to write minus 14 times the cube root of 2. And now notice these are all cube roots of 2, so I can say 9 minus 2 is 7, minus 14 is negative 7, so this would be negative 7 times the cube root of 2, and that would be my answer there. All right, I hope this is starting to make some sense. You feel a little bit better about it now. Let's take a look at this one here. All right, so I got 4th root. So once again, use your chart if you've got to. I want to break this apart. So this would be, the biggest one would be cube root of 16 would go in there. Times the cube root of 3. I mean the 4th root, excuse me. This one I can't do anything with. And this is a cube root this time, so this would be cube root of 8 and cube root of 9. Okay, so simplify. This is 2. It doesn't change. This is also 2. All right, so 14 times the 4th root of 3 minus 2 times the 4th root of 3 plus 6 times the cube root of 9. All right, so that means I can put together these first 2, but that's it. So because they're 4th roots of 3. So this would be 12 times the 4th root of 3 plus 6. Okay, and that's my answer. All right, hopefully this is now kind of starting to lock in here for you a bit. So we're gonna do one more, and this one I'm just gonna go a little bit faster to make sure this makes sense. I'm gonna break this apart into the cube root of negative 8 times cube root of 7. And then this would be 25 and 7. So I have 10 times 2 times root of 7. Let's go, that would be negative 2. So I'm going to say that. And this would be 4 times 5, root 7. All right, so I have 20 root 7 minus 2 times the cube root of 7 minus 20 root 7. Okay, be careful now. They all have a radicand of 7, but this one here is the cube root, okay? So that's important to note. So I can't put those together with the other ones. And you'll notice that means I can put this one and this one together. Well, they cancel out. One's positive, one's negative. So I really just end up with negative 2 times the cube root of 7. All right. That's how we add and subtract radicals. One last thing I want to go over is what happens when we have some variables in there. So this is the same premise, but I do want to go over one that's like this. Okay, so same thing. I'm going to break it apart. And let's do it. So I'm going to do square root here. What goes in there? Perfect square, and what's left over. Okay, so 49 times 2 gives me 98. And then this is the square root, so x to the 4th, y squared all goes here. So I guess I would just have that square root of 2 would be left over. Okay, and now this right here, let's see, I can't simplify the square root of 2 anymore. Okay, so now I need to simplify this first one. Square root of 49 is 7. And then x to the 4th, take the square root, is x squared. And this would be y. Now times the square root of 2 minus 3x squared y times the square root of 2. All right, now in order to add or subtract these have to be the same. But also, the coefficients have to be, now because they have variables, they have to be the same as well. They are, so that means I can put together the coefficients. If they weren't, we would not be able to add or subtract these. So this would be 4x squared y times the square root of 2. And that's how you deal with variables. Okay. This is adding and subtracting radicals. Hopefully this makes some sense. Your assignment is to do that, add and subtract radicals. There's only 6 problems. Make sure you get that done. Don't forget to write this in your planner, your student assignment book for today's date. And that's it. Have a good one.